There we go. Alright, back to Haskell. Record syntax. Record syntax? There's a cat right here. Okay, we've been tasked with creating a data type that describes a person. The info that we want to store about that person is first name, last name, age, height, phone number, and favorite ice cream flavor. What's your favorite ice cream flavor? I think I always go for strawberry. Strawberry and chocolate. I don't eat ice cream anymore. I haven't eaten ice cream for years, it feels like. 2 years since I quit sugar? Maybe, huh? I don't know about you, but that's all I ever want to know about a person. Let's give it a go. Let's give it a go. Untitled Chapter likes chocolate. Chocolate is great. Cookie dough, says Node Runner. That's pretty good stuff as well, yeah. Wait, wouldn't the best... Why... Oh, wow. I was thinking... Ooh, here we got the comparison with C and... Right, in Python, the way you would do this... create data that describes a person, you would do the... what's it called again? The dictionary, the map, the key value setup, right? Well, in C, you would create a structure, a data structure, a struct. And that's what we're doing here as well, a data structure. I assume that a data structure is... Or a data type, sorry. A data type is... superior when we're talking about efficiency and whatnot. So we create a data person where, of course, person, it can only be a person. We can't have a cat because cats can't eat ice cream. I don't know. Colgate in on tap says, I think this is how you would do a phone book that you discussed during pairs. Oh, that you would do a phone book. Yeah, like this, right? This seems to be more efficient. I think I'm gonna piss the cat off a little bit. Just wanted him to be closer. I had to stretch my arm just to cuddle him. Now he's gonna run away anyway, so... Okay, the first field is the first name, second is the last name, the third is the age, and so on. Let's make a person. I kinda like this... I like this way of making... a data type. It's very straightforward, right? Set a name and then you... Shit. Well, the data type is person and then... Shit, I don't remember the names of these things anymore, right? We have... This is the name of the data type. This is... what it is. Right, you could have... You could have a pipe symbol here and say like cat, right? And we could have different set of things here if we wanted to. Like they did with shapes, right? They had shape and then they had, I don't even remember, rectangle and circle. Right. And then all the different... different values that build this data type, yeah. And I think we always want to derive show. Well, we only want to derive show if we ever want to print this data type. Yeah, so a person, and if we're doing like a phone book or whatever, of course we want to print the things, so we derive show. But you can do helper data types, like we talked about before, yesterday, right? Where you... Right, we were talking about making modules, right? And you might make a module that has its own data type that's just helping out within the module, but you don't want to export it. Right, let's make a person. Let guy be... I forgot what the let was about again. Why did we do this? Let guy be equal to... We'll get in on tab says anti-piracy ads be like, you wouldn't print a person. Nice. So this, yeah. Oh man. Anti-piracy and anti-sharing ads. Yeah, there we go. Anti-sharing ads. It's not anti-piracy, it's anti-sharing. Right, Buddy Finkelstein. Oh, he likes chocolate as well. Look at that. And since we're just calling guy, yeah, and we're deriving print, we get the guy, yeah. Oh man. I'm yawning today. That is kind of cool, although slightly unreadable. What if we wanted to create a function to get separate info from a person? A function that gets some person's first name, a function that gets some person's last name, etc. Well, we'd have to define them kind of like this. Oh, right, because they are individual values. So would we just instead just put brackets here? No, sorry. Did we just put brackets here? That's my guess. That we're gonna put all this in brackets. So person is a list of all of these things. No. Parentheses. It has to be a tuple. It can't be a list because you can't have a list of string, int, float, string. A tuple would make more sense as well because you can't have a longer or shorter list. No, you have a 1, 2, 3, 4, 5, 6 item tuple with a string, an int, and float, a string, and another string. Calling that. Pretty close? Pretty close. Nice. Right, yeah, because this is a mess. That's a mess. Phew, I certainly did not enjoy writing that. Despite being very cumbersome and boring to write, this method works. Wait. Oh yeah, it works. It's a mess, but it works. But it's kind of a mess. There must be a better way, you say, yes. Well, no, there isn't, sorry. Just kidding, there is. Oh, I did not see this coming, there is a better way, oh no. The makers of Haskell were very smart and anticipated this scenario. They included an alternative way to write data types. Here is how we could achieve the above functionality with record syntax. Oh. Curly braces, not parentheses. So it's a specific thing just for data. Data declaration, data type declaration. Right, where everything get their own name. Right, so we can just call person.firstname and we will get body. Is that how it works? So instead of just naming the field types one after another and separating them with spaces, we use curly brackets. First we write the name of the field, for instance first name, and then we write a double colon, also called... Wait, is that Amium Necudioteum? Is that real or... I don't get the joke. And then we specify the type. The resulting data type is exactly the same. Oh, the main benefit of this is that it creates functions that look up fields in the data type. By using record syntax to create this data type, Haskell automatically made these functions. Oh, right. So we're just creating functions here. Right. Automatically. Yeah. It is another name for colon? Is it? I didn't know that. That's an awful name, yeah. To be fair, colon is a pretty bad name as well, isn't it? There's another benefit of using record syntax. When we derive show for the type, it displays it differently if we use record syntax to define and instantiate the type. Okay, say we have a type that represents a car. We want to keep track of the company that made it, the model name and year of the production. Watch. Car, string, int, driving show. Okay. Okay, we just get all that. If we define it using record syntax, boom. Car, company, oh wow. This looks like just like we have a key value pair, but we have a function value pair, right? But we got it's like a static thing. It's a data type. What's this? In PHP, the scope resolution is scope resolution operator, and there it is. The Hebrew thing. Second world colloquial corruption. Wait. Double colon in Hebrew. Wait, it literally means double colon in Hebrew? So it's just a Hebrew name of it. Why would we not say it just in English? Why do we say it in Hebrew? I'm not saying it in Swedish, I'm saying it in English. Actually, I don't even know what they're called in Swedish, but you get my point. I suppose we do say stuff in Latin and whatnot, so why not Hebrew? Sometimes stuff is said in Latin, sometimes stuff is said in Hebrew, sometimes stuff is said in ancient Greek, right? That's just... I assume, well... Bravely developed. Oh, right. I was thinking that it was like a leftover from the... No, that would be Arabic. Arabic. That's weird that there is not more Arabic, like Arabian? Fuck, I don't know what the name of the language is. Right? There was this part in history where like a lot of maths was created in some Arabic country, right? They didn't speak Hebrew then, or write Hebrew, I don't know. My language history is not the best. I don't know these things, as you may have noticed, yeah. Right. I kinda like this, yeah. When making a new car, we don't have to necessarily put fields in the proper order as long as we list all of them. But if we don't use record syntax, we have to specify them in order. Use record syntax when a constructor has several fields and it's not obvious which field is which. If we make a 3D vector data type by doing data vector int, it's pretty obvious that the fields are the components of a vector. Yeah. However, if our person or car in our person and car types, it wasn't so obvious, and we greatly benefited from using record syntax. Agreed, yeah. Well, tab says that the name was introduced in Israeli developed Zend engine. Yeah, exactly. That what the Wikipedia thing said, right? Yeah. I guess I can do the same if I ever make something programming stuff. Well, I guess Sweden already does that. You have a lot of furniture that is just named after random Swedish words. Yeah. Music is a little bit low. Like I don't hear anything. Like at all? Try that one more time. There we go. Get some more music. Where were we? Yeah, that wasn't. We have type parameters. A value constructor can take some value parameters and then produce a new value. For instance, the car constructor takes 3 values and produces a car value. In a similar manner, type constructors can take types as parameters to produce new types. Remember these names. This might sound a bit too meta at first, but it's not that complicated, isn't it? If you're familiar with templates in C++, I'm not, you'll see some parallels to get a picture of what type parameters work like in actions. What type parameters work like in action. Let's take a look at how a type we've already met is implemented. Data may be a... data type may be a equals nothing or just a. Right. That is value constructor can take some value parameters and then produce a new value. So our maybe type is just a or nothing. So our data type is derived from something else. Oh man, this was a little bit confusing. Type constructors can take types as parameters. Is this the parameter we're talking about? Maybe it's a type. Yeah, maybe a, this is the type. Maybe is the type constructor. Man, oh, all these names. What we end up with is a data type that is either nothing or just a. Right? We have to have the a in here because maybe what, right? Maybe something, which is this thing. And since we have the a, it can be anything. Maybe a or nothing. All right. The a here is the type parameter. Okay. And because there's a type parameter involved, we call maybe a type constructor. Depending on what we want this data type to hold when it's not nothing, this type constructor can end up producing a type of maybe int, maybe car, maybe string, etc. No value can have a type of just maybe. Yeah, that would be weird. Because that is not a type per se, it's a type constructor. Oh, right. So maybe constructs a type. This is, oh yeah, it is meta, right? You're constructing types on the fly. That's why it's called a type constructor. Because it's constructing a type on the fly depending on if we have a car, a string, an int, right? Right. In order for this to be a real type... More yawning, eh? Oof. In order for this to be a real type that has a value, that a value can be part of, it has to have all its type parameters filled up. So if we pass char as the type parameter to maybe, we get a type of maybe char. The value just a as a type of maybe care, for example. Exactly. You might not know it, but we used a type that has a type parameter before we used maybe. That type is the list type, although, yeah, we create one list or another list. Isn't the tuple as well? Yeah, the tuple takes... Actually, the tuple takes any... There's like an infinite list of possibilities here. Or ways to construct a tuple. Right. The list type, yeah. Although there's some syntactic sugar in play, the list type takes a parameter to produce a concrete type. The values can have a list of ints type, a list of characters type, a list of strings type. But you can't have a value that just has a type of a list. Right, even when we call an empty list, we have like a type inference, right? Our type inference makes it into one of these. And even when we use this, it's not really an empty list because it has... It's like we have... We don't have... We don't really have this. We might have like this. It's just it's not a character in there, right? If we have a list string, right? Just nothing in there, but there is a type of nothing that's in there. Untitled said that an empty list for lists is what nothing is for maybes. Pretty much. They're not equivalent, right? But they are similar in a way. Because this, it's still an empty list of ints, right? That's the type. It's not a list without a value in it. It's a list, an empty list of ints, right? Because of the type inference. But neither knows their actual type without outside help. Yeah, oh, right. I understand. Yeah, exactly. Because we don't know what this is without... yeah, we need a type inference to make sure. Just like just A has a type of maybe character. We don't know that... Well, no. Well, that was not a good example, but... Alright, let's play around with the maybe type. Just haha is just haha. Just 84 is just... yeah. We'll get the type of just haha, which is... maybe a character, exactly. Maybe a list of characters. Just 84 is... Wait. Just 84 is... oh yeah, it has to be a number, yeah. Maybe T. Nothing is maybe A. Yeah, it can be anything, right? Yeah. Is 10 maybe double? Yep, that makes sense. Type parameters are useful because we can make different types with them depending on what kind of types we want contained in our data type. Exactly, yeah. It's the same kind of attitude as with the generalized functions, right? You want to make tiny functions that are hyper generalized that you can use with many different data types. And since we want to do that, of course, we want data types that reflect that. A data type that can be, yeah, right, whatever its building blocks are, right? It's like here, it builds a... Yeah. Type constructors. I like it. Alright, where we are. When we do the type of just haha, the type inference engines figures out that it has to be, figures out to be the type of maybe a list of characters. Because of the A in just A is a string, then the A in maybe A must also be a string. Exactly. Notice that the type of nothing is maybe A. Yeah. Its type is polymorphic. If some function requires a maybe int as a parameter, we can give it a nothing because a nothing doesn't contain a value anyway, so it doesn't matter. Yeah. The maybe A type can act like a maybe int if it has to, just like 5 can act like an int or a double. Similarly, the type of the empty list is a list of something, right? Of anything. An empty list can act like a list of anything. That's why we can do... Yeah, exactly. Now this is a list of ints because of type inference. Or, well, it doesn't have to be ints, but you get my point. It's a list of nums. This is a list now of strings. Yeah. Using type parameters is very beneficial, but only when using them makes sense. Usually we use them... usually? No. When our data type would work regardless of the type of the value it then holds inside it. Like with our maybe A type. If our type acts as some kind of box, it is good to use them. We could change our car data type from this to this. Right, this is more restrictive, and this we could do either way, right? This could year, for example, could be an int, but it, right, depending on what we're working with, right? If we're importing information, then maybe our information that is coming in is not an int, but it's a string. Maybe we could have like the string 1984, like a, yeah, the character 1, the character 9, the character 8, and the character 4 in a... So doing it this way might be... Well, it depends on how you want to do it, right? It's if it makes sense to do it that way. I would probably argue that it doesn't make sense. So instead we would take our data, if we came with a data where we had a string that represented a year, I would turn that into an int before putting it in my data structure, right? Before constructing a car. I would probably do that because an int is way more useful than a string, isn't it? Well, it depends on what we're doing, I suppose, but yeah, and that's the point. It depends on what we're doing. Yeah. But would we really benefit? The answer is probably no. Yeah, exactly. Probably no, but maybe. Because we just end up defining functions that only work on the our string int type. For instance, giving our first definition of car, we would make a function that displays the car's properties in a nice little text. The problem as well, right, is that we could get two different cars that, right, with this thing we could have, in our program, we could have one car that had a different data type than from another car, right, since we have a type constructor. And maybe if we care about cars and we care about these things, we don't want that. We want them all to be one data type so we can play around with them, right? Maybe we have thousands and thousands and thousands of cars. We don't want these cars to be like 50% of them is going to be this data type and 50% is going to be a data type where there's a string. String instead of string int. We definitely don't want that. That would suck. Yeah, oof, that would suck. Alright, for instance, giving our first definition of car, we could make a function that displays the car's properties in a nice little text. Right, tell car. Alright, yeah, this was made, boom, 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 and all of that is fine. Alright, since we're calling show, doesn't this work the other way around as well? Tell car, yeah, this Ford Mustang was made in 1967. Exactly. A cute little function. The type declaration is cute and it works nicely. Now what if we, if car was car ABC? Doesn't that work as well? Right, we'd have to force this function to take a car type of show a car string A. Right, you can see that the typed signature is more complicated, and that the only benefit we'd actually get would be that we can use any type that's an instance of the show type class for type C. Wait. Show A. Wait, why do I have to do it this way? I mean, the function looks the same, right? Yep, the function looks exactly the same. It's just the type declaration. Why do we have to... Can't we just take car and a string? Wouldn't type inference work on this as well as this? Why not? Ford Mustang was, yeah. Tell car, tell car. Because the latter car is a type constructor. Yeah, but we do a constructor, right? But when we construct, right? That's at the point of constructing, don't we end up with the exact same, well, yeah, the same type, right? Isn't that the benefit of the type constructor, that we construct a type at this very time, right? Yeah, look at this. Here we go. Yeah, we take car, we get a Ford Mustang, we get... Yeah, exactly. We get car, and then T for a number for some reason. It picks T there. Oh, because we haven't told it. But here we get car, right? Both of these can be... Oh no, because we have to... I see it now. We have to do the show Y. That's the problem. If this is a string, we don't have to show on this. But show would work, wouldn't it? Right? If we take GHCI and then will that work? Like show hello. No, it doesn't. Yeah, because... Yeah, it fucks it up. It would fuck it up. I mean, it works, but it would fuck up the syntax. We would have to, yeah. No, not the syntax. It would mess up the output, right? That's not the output we want. We don't want a lot of backslash double quote signs. Definitely don't want that. Type is car ABC in the ladder. Yeah, exactly. The type is ABC while it's type string int. So our function, this function, we can't call this function because it would break if this is not an int, right? If this is a string, it breaks our function. Yeah. I get it now. No, what's that thing again? Yeah, we don't want any side effects. No side effects. You hear me? No side effects. That would be a side effect. Very strict. I think I like it. Maybe we should go and see a dominatrix. Who knows? In real life, though, we'd end up using car string int most of the time, and so it would seem that parameterizing the car type isn't really worth it. Yep. We could imagine places where it was worth it, right? We could imagine. We usually use type parameters when the type that's contained inside the data type's various value constructors isn't really that important for the type to work. A list of stuff is a list of stuff, and it doesn't matter what type of stuff it is, it can still work. If we want to sum a list of numbers, we can specify later in the summing function that we specifically want a list of numbers. Same goes for maybe. Maybe represents an options of either having nothing or having one of something. It doesn't matter what type of that something is. Exactly. So it is a little bit meta, like I said in the beginning, right? Wait. Alright, we're fine. Another example of parameterized type that we've already met is map, key, and value from data.map. The key is the type of keys and the map is the type of the values. Yeah, exactly. They don't have to be, even though it would make a lot of sense to use the key as a string, right? You don't have to. I remember when we looked into that, yeah. This is a good example of where type parameters are very useful. Having maps parameterized enables us to have mappings from any type to any other type, as long as the type of the key is part of the ORD type class. If we were defining a mapping type, we would add a type class constraint in the data declaration. Okay, wait. If we were defining a mapping type, we would add a type class constraint. Oh, right. That's the new part. Yeah, we need a data constraint, and I remember that. Yeah, it needs to be ORD. However, it is a very strong convention in Haskell to never add type class constraints in data declarations. Why? Well, because we don't benefit a lot, but we end up writing more class constraints, even if we don't need them. If we put or don't put the ORD k constraint in the data declaration for map, we're going to have to put the constraint into functions that assume that the keys in the map can be ordered. But if we don't put the constraints in the data declaration, we don't have to put ORD k in the type declarations of functions that don't care whether keys can be ordered or not. An example of such a function is toList, that just takes a mapping and converts its associative list. It just takes a mapping and converts it to an as list. Its type signature is toList. Right, yeah. We have a map of keys of anything into a list of tuples where we have key and value. Yeah. If map key KV had a type constraint in its data declaration, the type for toList would have to be toList or yeah, even though the function doesn't do any comparing of keys by order. Right, yeah. We would prefer to utilize the type inference, right? Type inference, like it said in the beginning, is very strong. It's very useful. So it's better to use the type inference rather than to make this mess. Okay. So don't put type constraint into data declarations, even if it seems to make sense, because you'll have to put them into the function type declarations either way. Yeah. Let's implement a 3D vector type and add some operations for it. We'll be using a parameterized type because even though it will usually contain numeric types, it will still support several of them. Wait, several of what? Oh, it doesn't have to support numeric types? Wait, why not? Why wouldn't we want always numeric types? Oh, several different numeric types. Right? We can't put type classes in here. And like it said, we don't want to put those restrictions up, I suppose. Right, it's deriving show, and then we have, what is this? B plus? Yeah, here we got the number constraint. We put that in the function instead, the num constraint, right? And we have vector. Oh yeah, and we add 3 vectors together. Sure. No, 2 vectors together. Sorry, there's just. Yeah, we add the 2 vectors together. I was wondering. Wait, what? It's because it's 3 variables in a vector. Yeah. Or 3D vector. There we go. Right, v plus is for adding 2 vectors together. 2 vectors are added just by adding their corresponding components. Yep. Scalar mult is for the scalar product of 2 vectors, and vect multi is for multiplying a vector with a scalar. Scalar? These functions can operate on types of vector int, vector integer, vector float. Whatever, as long as the a from vector a is of the num type class. That's, yeah, we define that here, not in the data type. Also, if you examine the type declarations of these functions, you'll see that they can operate only on vectors of the same type, and the numbers involved must also be of the type that is contained in the vectors. Notice that we didn't put a num class constraint in the data declaration because we'd have to repeat it in the functions anyway. Exactly. Yeah, but they have to be the same. Yeah, all of these have to be the same, which makes sense. Once again, it's very important to distinguish between the type constructor and the value constructor. When declaring a data type, the part before the equal sign is the type constructor, and the constructors after it, possibly separated by a pipe symbol, are value constructors. Right, we got the type. Wait, yeah, we got the type equals value. And we can construct the type and construct the value. Or we can have type constructors and value constructors. And do we always want value constructors, right? Yeah, like if we didn't have value constructors, it wouldn't make any sense making a data type, because the whole point of creating your own data type is that you want a unique, or you want your own value constructed. Yeah, otherwise you would just use the types that already exists, right? Given a function a type of vector TTT or Untitled says unless we want to make an empty data type. Wait, why would we want to make an empty data type? Similar to the maybe ones, you mean? Oh yeah, but yeah, right, then we would just... How would that even work? It would just be a data empty is equal to, and then just nothing. Why would we do that, Colgate on type? Probably not possible. Yeah, probably not possible. Yeah. And even if it was possible, there's no utility to it, right? Feels like we're moving towards no code again. Best Git repository, is that the name for it? In GitHub, yeah, the no code. If you haven't seen it, look into it. The best, yeah. That would be the data type without the value constructors. Yeah, exactly. So my point still stands that you always want value constructors if you're constructing data types. Maybe. Right, given a function type of vector TTT into T would be wrong, because we have to put the types in the type declaration, and the vector type constructor only takes one parameter, whereas the value constructor takes 3. Let's play around with our vectors. I was a little bit confused by this. Alright, we have a vector this, and we plus our vector together. Yeah, that works. That works as expected, right? And we multiply our vectors with 10. That works as expected. And vector and then scalar mult. I didn't know what this does. I don't know vector maths because it's maths, right? More maths. Oof. Luckily, we don't have to learn maths. Just a tiny bit, I suppose. You can do programming without maths. Not completely, but you don't have to know vectors. What time are we at? Is it lunchtime and we derive instances tomorrow instead? Is that it? I feel like maybe we derive instances tomorrow. Feels like a good spot to end. Yeah. Maybe a little bit early lunch. Alright, so thanks for hanging out. Yeah, and have a good one. Cheers.